Hello and welcome to this talk. My name is Michael Höfler and I will give you a short summary on two papers that we have published on what we call valuable exploration. First part is about how to make a strict difference between confirmation and exploration, and the second one is what are aims of exploration and how to conduct actually explorative analysis. First key idea is that exploration must be transparent. If it's transparent, then it's clear that we are using exploration in order to improve existing claims or generate new claims. On the other hand, intransparent or hidden exploration is used to create seemingly evidence for hypothesis or finding hypothesis in the data and pretending that it has already been confirmed. So this is called secretly hacking. Secretly hacking is a bad thing, but there's nothing wrong with transparent hacking if we are honest in that we did exploration. So in that sense, the freedom that you have in analyzing data is both a curse and a blessing. We will see that confirmation and exploration are pretty much blended in what you can see is published in papers. Therefore, the aim is to resolve the blending and to elaborate on what exploration could be once it is transparent. So we need means to valuable exploration. On how to conduct exploration, on defining some goals that exploration should have, and give some guidance on how explorative research could be implemented in the publication system. The blending of exploration confirmation does not come as a surprise. Firstly, there's no obvious boundary between the two. And second, almost everything in psychological research is based on p-values, so the same method is used for both. Evidence for blending comes from self-reports and from content analysis. Most importantly, blending harms scientific communication, so it's difficult for us to assess when we read results in a paper what is a soundly confirmed claim and on the other hand what is just a new claim or modified claim that is based on exploration, maybe hidden exploration. We suspect the main reason behind it is the pressure to produce seemingly confirmative results. This has been addressed by pre-registration. We believe, like others, that this should become mandatory because otherwise there's no control on whether an analysis or a hypothesis has been found only in the data and had not pre-existed before. Anyway, we believe that pre-registration is not enough, that the pressure partially resists pre-registration. This can be seen by most researchers not using pre-registration, by compliance problems that have been reported, or there is indication for some researchers using pre-registration just as an option to pull in case of success, and otherwise not to use a pre-registered report in case of a negative result, for example. And the whole thing might be explained by a certain fear that research has been in vain in that case of non-confirmation. Here we need to mention what we consider is proper confirmation. Confirmation is defined by an evidence norm that must be passed, namely in a severe test, a test that is very likely to fail if a claim is wrong. And the norm serves to define a boundary between a new and a provisorily accepted claim. The usual norm simply states that p must be smaller than alpha, but other norms may be defined. Please look into the first paper for alternatives. The core point here for pre-registration is that a norm must not be affected by what is found in the data in order to make researchers accountable. For instance, alpha must not be made smaller than it was required to be beforehand. For example, trend significance is not allowed if alpha has been set to 5%. And the other key idea of pre-registration is that it must be as detailed to define when exactly one would consider a claim to be confirmed and when not. Now, our idea to address the remaining pressure is to create a culture of valuable and transparent exploration, because science has often been argued to be most productive if the two conceptions, confirmation and exploration, feed into each other. Anyway, there is little transparent exploration that can be found in research papers. We believe that this is because there are little competences in exploration. So therefore, researchers lack methodical standards for having confidence in their own explorative analysis, and the same problem applies when exploration of others should be accepted. After this first part, we are ready to ask what actually is explorations, which goals it should serve, how should explorative analysis be done through filtering the results and smoothing over random patterns. This is the toolbox that we will look at, and we will end up with some recommendations to implement more exploratory research. So basically, we consider exploration as a quantitative quest for data patterns like associations, and these may give rise to modified or new claims. These could be either confirmed or disconfirmed in new data, in other data. That's important. And if this is transparent, there can be nothing wrong with that, because we do not make a false assertion about whether a hypothesis is true or not. Of course, we have to be very careful in the wording to make this very clear. We suspect that many researchers have the fear that after non-confirmation, all their work has been in vain if they don't get their hypothesis confirmed. But this is completely wrong. No matter whether a claim is confirmed or not, you may go on with analyzing your data in an explorative, transparent way. So there are many common practices that are only wrong if they are intransparent, if they are misused to create seemingly confirming results. So even if you have confirmed a hypothesis, you're allowed to make it stronger. For example, by not just claiming that an effect exceeds zero, but it exceeds delta, maybe a delta chosen by clinical significance. Or hypothesis may not be confirmed, then you might anyway go on, also if a hypothesis is confirmed, with subgroup analysis. So by doing so, you may suggest that your therapy is effective, but only in females. This does not make an assertion. It only invites somebody or yourself to create new data, to collect new data for a proper confirmation test. We believe that exploration has two conflicting goals. The first one, and maybe most fundamental one, is comprehensiveness. So the idea is that exploration should look at every pattern in the data. One should embrace the potential to discover anything in a data set that would bring science forward. On the other hand, exploration should be efficient. What do we mean by that? We should only look for patterns that are both true and relevant. True means that we should filter the signals out of the noise, and relevant means that we are looking for patterns that would move science forward if they are hiding truth. And relevant may refer to such ideas like magnitude of an effect association or practical or clinical significance. It has been stressed that for both a data set may entail many patterns which could be random or irrelevant. So we don't want to have all of them, we want to reduce them to a small number of those who really move science forward. Now look on the following illustration what we mean with efficiency and comprehensiveness. On this figure you see a lot of dots. Each dot is a data pattern, could be an association, and we are looking for the green dots. That would be called the dots of scientific interest. And we use a conception that we call the explorative search space. Like one ellipse, we have here a bigger ellipse in orange and a smaller ellipse in blue could define what data patterns we are actually exploring. So with the blue one, the narrow one, called S1, we would be able to cover 4 out of 6 true data patterns of interest. That would be rather effective, but it would be not so comprehensive. A more comprehensive choice would be the orange one, S2, but that would only add one more green dot, one more data pattern of interest. And it comes at the cost that we may come up with several false positive results. And in that sense, that choice would be less efficient. Let's assume that we have chosen explorative search space S1. Within these boundaries, we have analyzed 26 associations, and of course we don't want to interpret all of them because they could be all patterns of no interest. Thus, we want to reduce them to a few patterns which are patterns of interest. Thus, we want to do some kind of filtering to reduce them, hopefully, to those who are really would really bring science forward. So in that example, we would reduce them to 3 patterns, and 2 of the 3 could be patterns of interest. And finally, we would make some claims out of that. They could be similar to the associations, like 3 separate associative claims, or we could summarize them if they are similar in substantive terms. So the aim is to come up with only a few relevant, interesting, hopefully true claims. So how could we do filtering? Of course, the most obvious method are statistical tests. And with the choice of alpha, you may regulate how much filtering you want to use. The smaller alpha, the more filtering you are applying. Then you could use nearly everything from the statistical toolbox to do filtering, to filter your data patterns, beginning from descriptive analysis over various machine learning methods or Bayesian methods, which allow to express skepticism uh, like filtering out everything that does not pass skepticism and including bias. Finally, very importantly, you may use internal cross-validation if you have a really big data set, because then you may nicely combine the benefits of comprehensiveness and efficacy. Because you may take the first part of your data and do very much comprehensive data exploration, and whatever remains could be strongly filtered with the other random half of your data. The basic idea of everything, no matter which method you are using, the more filtering, the more initial evidence you have for your remaining patterns and claims that you derive for them. Thus, the more promising is a confirmation trial in new data. Thus, we want to do exploration in a way that invites promising confirmation trials. So far we have assumed that we could look at each data pattern separately, as if they were independent. But maybe they are correlated, and maybe we have some background knowledge that tells us how to arrange the observations along a dimension. Dimension could be time, or could be, in the example that we use now, genomic loci along the DNA strand. Thus we could focus more on global patterns using that background knowledge. And in that case, we would want to smooth away random error along the dimension even before analyzing the data, to get rid of that random error. That would help us a lot, and the aim is to identify the latent structure behind. For example, dependent variable y could be epigenetic stress depending on x equaling the genomic loci. And we would assume that the closer two loci are, the more similar the epigenetic stress response. We simulated this example to illustrate what we mean with smoothing. The blue line captures the true relation that we want to identify, or the latent structure that we want to approach by smoothing data. As you can see on the upper left in A, we don't apply any smoothing. We just have all these red peaks, and these don't tell us much about what is really going on, because there's so much random error on it. Then from B to D we apply smoothing through non-parametric regression. In B we don't apply much smoothing, we have too many ups and downs. As you can see, we are too far away from the true relation, whereas in C we reach a fairly good approximation. Finally, in D we apply too much smoothing. We are fitting actually a linear function, and this destroys the latent structure. This table summarizes some statistical methods that can be used to smooth data. It mentions over which search space you are smoothing, what you are actually smoothing, and the smoothing parameters, namely the parameters with which you regulate the degree of smoothing. For example, we had non-parametric regression in the example before, and the degree of smoothing was regulated through the degree of the polynomial that was used. Most importantly, the degree of smoothing depends on the degree of background knowledge that you have, that you put in. So the more you know already about a phenomenon, the more focused exploration might be. So the more you are already knowing what you are searching for and how the structure may look like, the more you can be focused in your analysis. With these considerations on efficacy, we are now ready to give some guidance on the question how many new claims one should raise through explorative analysis in a paper. And the answer is a small number, maybe suitable, maybe very small number. In order not to bother scientific community with confirmation trials later that might be likely to fail. And this takes care for trust in the hopefully developing new explorative trail to science. But the answer may be different for public repositories, because sometimes it's desirable to have all the results for everyone who could be informed, because a theory predicts some associations. And in that case, it might be nice to put all associations between all risk factors and all mental disorders in a table on a public repository, and not to do any filtering. The second paper concludes with a list of recommendations to stakeholders who have the means to implement more transparent exploration. I will not go through all of these points now, just mention that it would be very desirable for us to have a mandatory separation in a paper between what are confirmed or non-confirmed claims and what are the claims that have only be found in the data or modified through the data. And that should already appear in the abstract of an article. Other points relate to means where explorative analysis could be published in separate journals or in journal sections, for instance. I would like to conclude with the invitation to probe these ideas on how to do exploration, and let me know whether you find them useful. The paper includes several more aspects that I have omitted here. Yeah, if you're interested, please go through the papers and contact me. Thanks a lot for listening. Goodbye.